All right, let's ponder some conceptual graphs here. We have two situations dealing with free fall motion. In number 29, we're throwing an object down off the top of a building with an initial downward velocity of 3 meters per second. And we want to sketch the graphs. First thing I'm going to do is take the 3 meters per second and put it on the right graph. 3 meters per second is a velocity. Okay, so it's going to go over here on the velocity graph. 3 meters per second downward would mean negative. So negative 3 meters per second. That's your initial velocity. So after the ball leaves your hand before it strikes the ground, it's in free fall motion, which means the acceleration value is a constant negative 9.8. So we're going to get a horizontal line across at negative 9.8. That tells us the slope of the velocity versus time graph. And so we're going to start at negative 3. And we have a slope value of negative 9.8. So it continues to pick up speed in that downward direction. Okay. Y versus t graph. Okay. We know the velocity is changing. So then we need the slope to change. We need the slope to start off at a negative 3 value, so it's going to start off going downward and get steeper downward. Now, where you start the line, it doesn't make any difference. If you want to call your starting place the origin, that's fine. I'm going to start it a little bit up here. So then what we have is the slice of a parabola. Okay, the peak would be somewhere further over, and we just have a piece. Because it didn't give you a certain frame of reference, this shape shifted anywhere up and down is perfectly fine. Okay. Now, number 30. A baseball is hit vertically upward. Make the graphs that represent the path from the time it leaves the bat to just before it hits the ground. So then it's starting off at the height of the bat. And since batters don't lay down on the ground, it's going to be somewhere above the ground. So then I'm going to say whatever that bat location it is right there. And so this graph's going to start off right there, a little above, I'm going to call 0, the ground. Okay, we're not given any specific numbers, but we do know it's in free fall motion. Going up, going down the top of the path, the whole way after it leaves the bat, the only thing acting on it is gravity. And so then our acceleration, just like the first situation, horizontal line at negative 9.8. Just like the first situation, okay, our slope of the velocity is going to be a negative 9.8. We just, like over here, we need to know where to start it. Well, we're hitting the bat upward, so then we need to start with some positive velocity, whatever that value is, and then I go down with a slope of negative 9.8. So then the whole way the ball is moving up, it has positive velocity. Right there, it stops at the top, so the velocity is 0, and then it continues into its downward motion. So again, the positive values here represent it's moving upward, the negative values here represent it's moving downward, and that point right there would represent the top of the path. Y versus t. Again, from our motion equation, delta y equals vi delta t plus 1/2 a delta t squared. This is going to be a parabolic curve. It's going to start with a positive slope value that gets less and less until the slope at the top is 0, and then the slope becomes negative and more negative because slope over here is equal to velocity. So then I'm going to start with a very positive slope, which becomes less and less positive top of the path, and then more and more negative. So your y versus t, the position graph literally looks like the path of the ball. Okay, so on free fall motion or any situation where you have a constant acceleration, your acceleration graph is going to be horizontal, which then will produce a constant slope on the velocity, and then a curve on the position. Ponder physics.